Hello my dear viewers, welcome to today's tutorial. I'll take you through Mathematics Paper 1, which was done in the year 2019. So this is the cover page, and therefore just stay tuned towards the end. I'm Michael Samuel, teacher. You're much welcome. If you haven't subscribed to my channel, kindly subscribe. You can also comment down there on how the video is. You can also share to your friend. And let us begin with the first question. So we have the first question. Which is, without using mathematical table or a calculator, evaluate. So we have 5.4 all over 0.025 times 3.6. So let us start working out this. So what we need to do here, counting the number of decimals in the denominator, it's 1, 2, 3, 4. The total number of decimal in the denominator is 4. So we need to multiply by 10,000. So multiply by 10,000. Also the same case we do with the numerator, we multiply by 10,000. So if we multiply by 10,000, the numerator part will be 54 times 1,000. 1 0 has been eliminated because of the decimal. All over, for the denominator, it will be 25 times 36. So we have 54 times 1,000 all over 25 times 36. So we need to factor out, we cancel out what is common. So we have by 25 1, here by 25 in 100 it goes 4 times, then we have 0. So that goes 40 times. Then by 4 we have 10, by 4 we have 9, by 9 we have 1, by 9 we have 6. So we end up having 6 times 10, which is 60. Then we move on to question 2. So we need to express 1728 and 2025 in terms of their prime factors. Hence we evaluate the cube root of 1728 all over the square root of 2025. So the first step we shall take is to get the prime factors of 1728. 1728 can be written in terms of the prime factors as 2 raised to power 6 times 3 raised to power 3. For 2025 can be written as 3 raised to power 4 times 5 raised to power 2. And therefore we are going to rewrite the square root, cube root of 1728 as the cube root of 2 power 6 times 3 cubed all over the square root of 2025 be written as the square root of the prime factors of 2025 is 3 power 4 times 5 power 2. So this can also written as, so the cube root of 2 power 6. Now this can be written as, so in another way can be written as 2 raised to power 6 times 3 raised to power 3, everything raised to a third, all over for the square root of 3 power 4 times 5 power 2 raised to a third. That's how it can be written as. And therefore now the cube root of 2 power 6 6 times a third is 2, so we have 2 power 2. Then times 3 raised to 3, 3 times a third, so we have 3 raised to 1. The other one is 3 raised to power 4, 4 times a half is 2, and therefore we have 3 raised to 2 times. The other one will be 5 raised to 2, 2 times a half is 1, so we have 5 raised to 1. So we end up getting, this is 4 times 3 all over, we have 9 times 5. So by 3, 1 by 3, we have 3. And therefore we end up getting 4 times 1 is 4, all over 3 times 5 is 15. And that is the answer for question number 2. So we move on to the next question. So for the next question, Juma left his home at 8:30 a.m. He drove a distance of 140 kilometers and arrived at his aunt's home at 10:15 a.m. Determine the average speed in kilometers per hour for Juma's journey. So we need to get the time taken. So the time taken in this case will be the arrival time at Juma's aunt's home and the departure time at Juma's home. So the arrival time is 10:15 a.m. The departure time was 8:30 a.m. and therefore we need to subtract. So in this case here, 15 is less than 30, so we need to borrow 1 hour from 10, so that we remain with 9, and therefore 1 hour is equivalent to 60, 60 plus 15, that is 75. Therefore 75 minus 30, that is 45 minutes, and then 9 minus 1, that is 1 hour. So this is also the same as 1.7 hours. Or 1 3/4 of an hour. So we need to find the speed in kilometers per hour. So speed is given as distance divided by time taken. And therefore the speed, so distance from Juma's home to his aunt's home is 140, so we have 140 kilometers. We divide by the time taken, which is 1.75 hours. And therefore, if we divide 140 divided by 1.75, we end up getting 80 kilometers per hour. So question number 4, expand and simplify. We have 4 into bracket q plus 6, then plus 7 into bracket q minus 3. So we need to expand and simplify, and therefore we need to open the bracket. So 4 times q, it is 4q, then plus 4 times 6, that is 24. Then 7 times q, so we have plus 7q. Then 7 times minus 3, we have minus 21. Collect the like terms and simplify. So we have 4q plus 7q, that is 11q. Then plus 24 minus 21, that is 3, and therefore we have simplified, so this will be 11q plus 3. We move to the next question. In the trapezium, PQRS shown below, PQ is equal to 8 centimeter and SR is equal to 6 centimeter. So if the area of the trapezium is 28 centimeters squared, find the perpendicular distance between PQ and SR. So we need to find the perpendicular distance between PQ and SR. That perpendicular distance, we can say let it be H. And you know the formula for finding area of a trapezium is given by the average of the two parallel sides multiplied by the perpendicular height. Area given is 28 will be equal to the sum of the two parallel sides, a plus b, that is 6 plus 8, which is 14, divided by 2, then times the perpendicular distance, which is the perpendicular height. Therefore, we have 28 is equal to 14 over 2, that is 7h. So we divide both sides by 7. So we end up getting the perpendicular height h, or distance, is 4 centimeter. We move on to the next question. Given that the cube root of 9 raised to power 4 is equal to 3n, find the value of n. So in this case here, we can rewrite this as 9 raised to power 4, then raised to a third, will be equal to 3 power n. Remember that 9 can also be written as 3 raised to 2, and therefore we have 3 raised to 2 raised to 4, and everything again raised to a third will be equal to 3 power n. So this will be 3 raised to 2 times 4, that is 3 raised to power n raised to a third will be equal to 3 power n. Again, open the bracket and multiply the powers. So this will be 3 power 8 over 3 will be equal to 3 power n. And since the bases are equal, we are going to equate the powers. So n is equal to 8 over 3. 8 over 3 is an improper fraction, so as a mixed fraction will be 2 and 2 third, and that is the value of n. Next, we move on to question number 7. Three villages A, B, and C are such that B is 53 kilometers on a bearing of 295 degrees from A, and C is 75 kilometers east of B. Using a scale of 1 centimeter to represent 10 kilometers, draw a diagram to show the relative positions of villages A, B, and C. So what I'm going to do first is to make a sketch for the relative position of the 3 villages A, B, and C. After that, I'm going to use the scale given so that I'll plot those points. Therefore, consider this as taking the north, and this point here is A. So we need to measure or just approximate 295 degrees from the true north. We measure it clockwise direction from the true north, and then that means point B is somewhere there. which is 53 kilometers. So since we are using a scale of 1 centimeter to represent 10 kilometer, so in scale drawing we shall use 5.3 centimeter. Then C is 75 kilometer east of B. So using the compass is north, east, west, south. So B is east of C is east of B, and therefore consider it somewhere there, which will be 75 kilometer, but 1 centimeter represent 10 kilometers, so 75 divided by 10, so we have 7.5 centimeter. That's what we shall use in our scale drawing, and then we shall be able to join A to C, and therefore after that we shall be able to answer the questions that follow.
So three villages A, B and C are such that B is 53 km on a bearing of 295 degrees from A, and C is 75 km east of B. Using a scale of 1 cm to represent 10 km, draw a diagram to show the relative position of villages A, B and C. Then part B will determine the distance in kilometer of C from A. So for this case now we need to have, and we just draw using a scale drawing 1 cm to represent. So the first thing we are going to locate the initial point of A. So let us locate initial point of A. I draw the compass direction such that I have E. So this case, that is the north, that's the north direction. So this is our point A. So here, that is point A. Therefore, B is on a bearing of 295 degrees. So remember we measure through compass true bearing from the north in clockwise direction, and therefore it will be this side. So from the north it will be 360 minus 295, that is 65. So let us measure 65 degrees in the north. So from here 0 all the way to 65, that's where 65 is, and therefore we are going to join the straight line from this. So use the ruler and therefore we draw that line. Then from there, B is 53 km from A, and therefore using the scale drawing, so 50 km divided by 10, we have 5.3, 5.3. So use our compass and measure 5.3. So 5.3, and put that mark. So that is 5.3. 5.3 centimeter. So from there now we have located point B. So that's point B. Again we need to, from here we draw the north, true north. That is it. Then C is 75 kilometer east of B. So east of B from this point. That means we need to measure an angle of 90 degrees. So let me set it. That's fine. So 90 degrees will be at that particular point, and therefore I am going to draw using a ruler. Then from there, now I need, from B it is 75 kilometers, so I need to locate point C, which will be 75 divided by 10, that will be 7.5. So I'll measure 7.5 from point B. 7.5. So that's 7.5. So I have located point C. That's our point C, which is 7.5 centimeter. So from there now, we have actually located the relative position of the villages A, B, and C, and therefore we need to determine the distance in kilometer of C from A. That's part B, and therefore I need to join point A to C. So point A to C, therefore let me measure that using a protractor. I measure it using this compass. Therefore, .5. So AC is 3.5 centimeter. But we need to get the actual distance. Remember, we use a scale of 1 centimeter to represent 10 kilometer. Therefore, 3.5 centimeter will represent, that will be 3.5 times 2 multiply times 10, and therefore we get, that will be that 5 kilometers. So the distance is
So for question number 8, a retailer bought a bag of tea leaves. If the retailer were to repack the tea leaves into smaller packets of either 40 grams to 50 grams or 350 grams, determine the least mass in grams of the tea leaves in the bag. So here the keyword is least mass, and therefore we need to find the LCM of 40, 250 and 350. So I'll use the prime factor method to find the LCM. So the prime factors of 40 will be 2 power 3 times 5. The prime factors of 250 is 2 times 5 power 3. The prime factors of 350 is 2 times 5 squared times 7. And therefore, to get the LCM the LCM, we are going to consider factors with a prime factor with the highest power, 2 power 3. The other one for 5 is common, but we take the one with the highest power. Then we take 7. So that will be 2 power 3 times 5 cubed times 7. 2 power 3 is 8 times 5 power 3 is 125 times 7. 80 times 125, that is 1000 times 7, and therefore LCM is 7000. Now, the question is determine the least mass in grams of the tea leaves in the bag. So that will be the least grams that will be required. Question 9. Given that sine 2x is equal to cosine 3x minus 10 degrees, find tan x correct to 4 significant figures. One thing we need to note here is that for complementary angles which add up to 90 degrees, if sine of angle A is equal to cosine of angle B, then A plus B are complementary angles and they add up to 90 degrees. And therefore, sine 2x is equal to cosine 3x minus 10 if we take 2x plus 3x minus 10 will equal to 90 degrees. And therefore, collect the like terms. 2x plus 3x, that is 5x, will be equal to 90 plus 1 plus 10, will be 100. And therefore, x, divide both sides by 5, x will be equal to 20 degrees. And the question is, we find tan x. X is 20, and therefore tan x, we need to find tan 20 degrees. Using a calculator, and we give the answer to 4 significant figures, that will be 0.3640, and that is to 4 significant figures. We move on to question number 10. A tourist converted 5,820 US dollars into Kenyan shillings at the rate of 102.10 per dollar, while in Kenya he spent 450,000 shillings and converted the balance into dollars at the rate of 103.00 Kenyan shillings per dollar. Calculate the amount of money to the nearest dollar that remained. And therefore, since we are converting, that is US dollar to Kenyan shillings, that's a foreign currency to the local currency, and therefore this is the rate per dollar. So we need in Kenyan shillings, so we have 5820 US dollar times the Kenyan shillings 102.10 per dollar. So dollar will comes out, and therefore 5820 times 102.10, we shall get 594,222 shillings, Kenyan shillings. So the amount that remained after, while in Kenya he spent 450,000. So that balance was converted at the rate of 103.00 per dollar. So the amount remained while in Kenya is that amount he had converted while in. So that is 594 222 minus what he had spent. So we get the amount remained in Kenyan shillings, 144,222 shillings. Now, again, he converted the amount that remained to Kenyan, that amount to dollars now. So that is Kenyan currency or local currency to foreign currency, and therefore we are going to divide. So we have 144,222 divided by 103.00. So the amount that is received, so you work out this is, but the question requires to the nearest dollar. So the nearest whole number, that will be 1,400 US dollars. So that's what actually remained and was converted to US dollar. We move on to question number 11. Given that vector B is 2, 4, vector C is 3, 2, and A is equal to 3C minus 2B, find the magnitude of A correct to 2 decimal places. So you need to find A is 3C minus 2B. So we need to substitute the values of vector B and C into, so A will be 3, C is 3, 2, minus 2, vector B is 2, 4. Then multiply by the scalar, 3 times 3, that is 9, 3 times 2, that is 6. Then minus 2 times 2, that is 4. Then 2 times 4, that is 8. So we subtract the corresponding elements. 9 minus 4, that is 5. Then 6 minus 8, that is minus 2. And therefore, we need to find the magnitude or the size of vector A. So it will be represented by, so the x coordinate squared plus, that is a change in x, then change in y squared. So for our case here, x is 5, so we have 5 squared, then plus, y is minus 2, we square it. So this will be 25 plus the square root of 25 plus 4, which is the square root of 25 plus 4, that is 29. And therefore, from the calculator, it is 5.385164807, but required to 2 decimal places, so that will be 5.3939 units, that is to 2 dp. So that's very important in following the instruction. We proceed on to the next question. So using a ruler and a pair of compasses only, construct a rhombus PQRS such that PQ is equal to 6 cm and SPQ is equal to 75 degrees. Measure the length PR. So I'm going to make a sketch of what we are expected to have. Then from there we draw. So we are supposed to use a ruler and a pair of compass. We construct this rhombus, and therefore PQRS. So the first thing we need to have is, so the first length we have been given PQ, which is 6 centimeter. Then the angle at P is 75, such that we have S, PQ, then R. So that's what will be required. After that, we find the length of PR, that is the longer diagonal of the rhombus. So let us go to the construction software and then we draw it. After that, we answer the question.
So question 12, we are going to use a ruler and a pair of compass only to construct a rhombus PQRS such that PQ is equal to 6 centimeter and angle SPQ is equal to 75 degrees. Then we are required to measure the length PR. Certainly before even we draw the actual drawing, we need to make a sketch so that we see how the figure will look like. So we have been given the length PQ, so let us have a sketch. We have PQ, so that is Q, and then we have Q, and then at P is where we have 75 degrees, so at this particular point. So we are going to draw this angle will be 75 degrees. And we know the properties of a rhombus such that all sides are equal. So here it is S, so vertex is S, and then R, so join this, and also, so that's where we are going to have R. So PQRS. So this angle is also 75. This angle here is 1 or 5. 1 or 5. And therefore, the first thing we are going to do for us to be able to construct an angle of 75, because we are required only to use a ruler and a pair of compasses. So first we are going to construct an angle of 90, then we construct an angle of 60, so the remaining 30 we are going to bisect it so that we have 60 plus 15, which will be 25. So let us draw PQ. So draw PQ. So let me locate P, so that is where our P will be. Point P. And from P to Q I measure 6 centimeter. 6 centimeter. So using a compass, we measure 6 centimeter. Point Q. So this is 6 centimeter. Then at P, we are going to construct a perpendicular point. So let me take mark so that I am going to draw a perpendicular. Then from there, I use the X that I've made as the radius. Then I'm going to use a different. So I put a mark. I also use the other arc as the center. Good. Mark above. Then I'm going to use a ruler and draw. So that is it. I have a perpendicular at P. So I need to construct an angle of 60 degrees. So I'm going to construct an angle of 60 degrees. Let me adjust. So put an arc there. And also above, maintaining the same radius with this arc, the center, and then put. Therefore, now I'm going to join using a ruler. That is it. Fine. Now, this angle is 60. Then the other one is 30. I need to bisect this angle again. I bisect that angle into 2 so that I have 15. I put a mark there, and also this one. Then I adjust the radius, going to adjust the radius and use this as the arc. Mark there, and also use the other mark as the radius, and then put a mark there. Then I'm going to join it. So that is it. And then try to measure. So that is 75 degrees. 75 degrees. So I need to locate point. I need to locate point S from P, which is 6 centimeter. So 6 centimeter. So that's where S is. S is at that point. Again, from Q to S is 6 centimeter. From Q to S is 6 centimeter. So again, I do the same. That mark. Also from S to R. From S to R is 6 centimeter. Again, I do the same. That arc there. Then this is R. Then I'm going to join S to R and Q to R. Then R to S. So that is the rhombus PQRS. All the sides is 6 centimeter. And now the all of this angle is 75 degrees. Then I am required to measure length PR. PR, this diagonal. So what I'm going to use, we use a divider, compass. Let me place one pointer at P, and then I adjust. So that is 9.5. So that means here R is 9.5 centimeter. So that's how that question is done.
Question 13, we are going to solve the inequality 2x minus 1 is less or equal to 3x plus 4 is less than 7 minus x. So here we are going to solve for x, and therefore in this inequality, since it's a combined inequality, we are going to simplify it. So the first inequality we shall take, we have 2x minus 1 is less or equal to 3x plus 4. Then the other inequality we shall have is the second inequality is 3x plus 4 is less than 7 minus x. So the first inequality, let us simplify it, collect the like terms. 2x minus 3x is less than or equal to 4 plus 1. So 2x minus 3x, that is minus x, is less or equal to 5. So to remain with x, we have to divide both sides by minus 1. The moment we divide by a negative number, the inequality sign will change, and therefore will be x is greater than or equal to minus 5. This can also, so that is it, or can be written as minus 5 is less than or equal to x. Next, the second inequality, we have, again we simplify, 3x plus x is less than 7 minus 4. Therefore, 3x plus x, that is 4x, is less than 7 minus 4, that is 3, and therefore divide both sides by x by 4. We have x is equal to 3/4, or could be x is less than 0.75. So now the combined will be minus 5 is less or equal to x is less or equal to 0.75. Since we need to solve the inequality, the integral values will be, here minus 5 is actually included, so we have minus 5, we have minus 4, minus 3, minus 2, minus 1, and 0. For integral values, we don't take, actually this is less than. Then question number 14. Given that matrix A is 2, 3, 4, 4, matrix B is x, 1, 2, 3, and that AB is a singular matrix, find the value of x. For a singular matrix, that means AB is a singular matrix. So the determinant of matrix AB will be equal to 0. So we need to multiply the matrix A and B first. Then from there, we equate it to 0, its determinant. So we have 2, 3, 4, 4, multiply by x, 1, 2, 3. So, to get the element in the first row, first column, we multiply the first row, first column, first row, first column. So you have 2 times x, that is 2x, plus 3 times 2, so plus 6. To get the element in the first row, second column, we multiply first row and second column. So 2 times 1 is 2 plus 3 times 3, so plus 9. To get the element in the second row, first column, we multiply second row, then first column. So 4 times x, that is 4x, plus 4 times 2, that is 8. Then to get the element in the second row, second column, so we multiply second row, second column. So 4 times 1, that is 4, plus 4 times 3, so plus 12. And therefore, let us simplify it. This will be 2x plus 6, 2 plus 9, that is 11, then 4x plus 8, then 4 plus 12, that is 16. And this, that is the the matrix AB. So we need to get the determinant. So the determinant of this matrix is 2x multiply elements in the main diagonal, so that is 2x plus 6 times 16 minus element in the other diagonal, 4x plus 8 times 11. Then let us simplify it. 16 times 2x, that is 32x, plus 16 times 6, so that is plus 96. Then 11 minus 4x, that will be minus 44x. Then 11 times 8, we have minus 88. So this will be 32x minus 44x, that is minus 12x. Then 96 minus 88, that is plus 8. So the determinant is equal to 0, and here this is the determinant of AB. So minus 12x plus 8 is equal to 0. So this implies that 12x is equal to 8, and therefore divide both sides by 12. So x is equal to 8 divided by 12. If you simplify it, by 4 3, by 4, by 4 2, by 4 3. So x is equal to that. We move on to the next question. A trader bought two types of bulbs, A and B, at 60 Kenyan shillings and 56 Kenyan shillings respectively. She bought a total of 50 bulbs of both types at a total of 2,872. Determine the number of type A bulbs that she bought. Therefore, we have two types of bulb, A and B, and the total number of bulbs is 50. Therefore, in this case, we are going to form an equation. So that means type A bulb plus type B bulb, the total will give us 50 bulbs. So call it equation 1. Then, for bulb type A, it was costing 60 shillings. So for A bulbs, it will cost 60A. Then for type B, one was costing 56 shillings. So B bulbs will cost 56B. And the total cost was 28.72. Again, we have formed another equation. So we need to solve for this simultaneous equation, and therefore from equation 1 we can write B in terms of A. So B is equal to 50 minus A. So we have formed equation 3. So let us substitute equation 3 into equation 2. So we shall have 60A plus 56. B is 50 minus A. Everything will be equal to 2872. So 60A, then plus, let us open the bracket, 56 times 50, that is 2800. 56 times A, we have minus 56A, then will be equal to 72. So collect the like terms, 60A minus 56A will be equal to 2872, then minus 2800. So 60A minus 56A, that is for A, will be equal to 2872 minus 2800, that is 72. And therefore, divide both sides by 4, so A will be equal to 72 divided by 4, we get 18. So the question wanted us to determine the number of type A bulbs that she bought, and therefore for type A there were 18 bulbs. Then the last part of section A, which is question 16. A bus plies between two towns P and Q, P and R, via town Q daily. On each day it departs from P at 8:15 a.m. and stops for 40 minutes at Q before proceeding to R. On a certain day the bus took 5 hours 40 minutes to travel from P to Q and 3 hours 15 minutes to travel from Q to R. Find in 24 hours clock system the time the bus arrived at R. So the first thing we are going to do, allow me to make a sketch. So from town P to town R. So the bus plies between the towns, but it passes through, so Q is in between P and R. And therefore, it departs from P at 8:15 a.m. and then at Q, the time it is stopped, Q it takes 40 minutes to stopping before proceeding to R. And therefore, we have been told that on a certain day the bus took 5 hours 40 minutes to travel from P to Q. It traveled that particular day for 5 hours 40 minutes. Then from P to Q, and then 3 hours 15 minutes travel from Q to R. It took 3 hours 15 minutes. So we need to find in 24 hours clock system the time the bus arrived at R. So we need to add the total time taken. So time taken from P to Q, it took 5 hours 40 minutes. Then it is stopped for 40 minutes, so we add 40 minutes. So 40 plus 40, that is 80 minutes. So that's 1 hour 20 minutes. So we have 20 minutes, carry 1 hour, 5 plus 1, that is 6 hours. Then from Q to R, it took 3 hours 15 minutes. We add again, we get, this is 35 minutes and 9 hours. So that is 9 hours, 35 minutes. So the arrival time, we need to find in time in 24-hour clock system, the bus arrived at point R. So the arrival time at R will be, so we had 08:15, so we add 9:35, so 15 plus 35, that is 50, and then we have 8 plus 9, that is 17, and that is 1750 hours. That is the time it arrived. So you have to give the answer to in 24 hours clock system, otherwise you'll miss that marks for instruction. So welcome to section B. So question 17, a rectangular water tank measures 2.4 meters long, 2 meters wide, and 1.5 meters high. The tank contained some water up to a height of 0.145 meters. So we need to calculate the amount of water in liters needed to fill up the tank. Then from there so part B of the question, have an inlet was opened and the water flow into the tank at the rate of 10 liters per minute. After 1 hour, a drain pipe was opened and water allowed to flow out of the tank at a rate of 4 liters per minute. So we need to calculate Roman 1 of part B, the height of the tank of water in the tank after 3 hours, and also part Roman 2, the total time taken to fill up the tank. So that's question 17. So we are going to answer it one by one. So we have the rectangular tank, so we need to find the amount of water in liters needed to fill up the tank. Since the tank already has water up to a height of 0.45 and the complete height of the tank is 1.5. So let us get the total volume of the tank, total volume. So the total volume is length times width times height, and in this case the length is 2.4 meters, width is 2 meters, and the height is 1.5. So if you work it out, we get 7.2 meters cubed. So volume in liters will be, so 1 meter cube is equivalent to 1 meter cube is equivalent to 1,000 liters, and therefore 7.2 meter cube we multiply by 1,000, and therefore we get 7,200 liters. So that's the total volume of the tank. So amount that is required, so the remaining height is 1.5 minus 0.45, and if we subtract, we get 1.05 meters. So volume needed to fill up the tank, that is 2.4, the length times the width 2 times height remaining 1.05. So if you work it out, we end up getting 5,040 liters. Then from there we are going to move on to part B of the question. Part B of the question. An inlet pipe was opened and water let to flow into the tank at the rate of 10 liters per minute. After 1 hour, a drain pipe was opened and water allowed to flow out of the tank at the rate of 4 liters per minute. So we need to, the amount of water already in the tank, is 2.4 times 2 times 0.45, and that is 2,000. With this again we multiply by 1,000, so it is 2,160 liters. That's the amount of water already in the tank. So you need to get the height of water in the tank after 3 hours, since you have been given the rate at which the inlet pipe flows, and also for the drainage pipe. Now, amount of water let in the tank after 3 hours. So since you have been given the rate, so it is 3 times 3 hours times 60. 3 hours times 60, that is, since 1 hour is 60 minutes, so that is after 180 minutes. And the rate for the inlet, the rate at which it flows, so the volume will be, so we have 10 liters per minute multiplied by 180, so that is 1,800 liters. So after 3 hours, the inlet will have let in 1,800 liters. Then we have after 1 hour, that's when the drain pipe was opened. So that means the drain pipe took 2 hours to let water flow out of the tank. So for the outlet which took 2 hours, and 2 hours is the same as 120 minutes, so 120 minutes times the rate at which it is flowing, 4 liters per minute, so times 4. So after 2 hours, the outlet pipe will have let 480 liters out of the tank. So amount after 3 hours, so the amount after 3 hours, amount after 3 hours will be what the inlet pipe has let in minus the outlet. So we get, so this will be so we subtract and we get 1,320. But remember that initially there was some water into the tank, which was 2,160, and therefore the total volume after 3 hours was 2,160 plus 1,320, and therefore we get 3,480 liters. The question is height of water in the tank after 3 hours. So the height of water tank so will be we have the total volume. So we are going to divide by, so we need to find the height. So divide by, so we have the width 2 times 2.4, again times 1000 since it is in liters, and therefore we shall end up getting 0.725 meters. So this is the height of water in the tank after 3 hours. Then the next part is the total time taken to fill up the tank, the total time taken to fill up the tank. So for the total time taken to fill up the tank, now height to be filled in this case is the height which is remaining. Height to be filled is 1.5, the total height minus now what we have 0.725. So what is remaining is 0.775 meters. So this is the remaining part to be filled, and therefore volume will be the length 2.4 times the width times 2 times height 0.775. So let us convert it just directly to liters, so multiply by 1000, and therefore we shall get 3720 liters. So this is what is remaining to be filled. And now the time taken will be this volume and the rate at which the inlet and the outlet pipe let in water and out. So the average will be, so the inlet is letting water at 10 liters per minute, and the outlet lets water at the rate of 4 liters per minute. So we are going to subtract, so this is in liters, and here it is liters per minute, and therefore this is that 720 divided by 6. If we divide by 6, we end up getting 620 minutes. 620 minutes is the same as 10 hours, 10 and a third, or 10 hours and 20 minutes. And therefore, the total time taken, initially it took 3 hours, and now the remaining part has taken 10 and a third hours. So if you add together, you get 13 and a third hours. So this is the total time taken, or you can say it is 13 hours, a third of 60 minutes, that is 20 minutes. So that's how we do question number 17. So we can proceed on to question number 18. So for question 18, part A, a line L1 passes through the points 3, 3 and 5, 7. Find the equation of line L1 in the form y is equals mx plus constant, where m and c are constant. Then after that, we are going to answer this part B. Another line L2 is perpendicular to L1 and it passes through minus 2, 3. Find the equation of L2 and the x-intercept of L2, and later we determine the point of intersection of L1 and L2. So let us do part A of the question. So the first thing we need to do, we have been given 2 points of L1, and therefore let us find the gradient of L1. So gradient of L1 will be given by change in y. So we have 7 minus 3. So 7 minus 3, that is the change in y coordinates. And then we take x and x, 5 minus 3, 5 minus 3. So this will be 7 minus 3 is 4, 5 minus 3 is 2, and therefore 4 divided by 2, that is 2. Then we can say, since we need to find the equation of L1, we say let another point xy, this is an arbitrary point, be on a line with either one of these points. We can take one of these points. Let me take 3, 3. So again, if you find the gradient of these particular points, then it should give us 2. So change in y minus 3, y minus 3 over change in x, x minus 3 will be equal to 2. And therefore multiply both sides by x minus 3. Therefore I'll have y minus 3 is equal to 2 multiplied by x minus 3. So I'll end up getting y minus 3 is equal to, open the bracket, 2 times x, that is 2x, then minus 2 times minus 3, that is minus 6. Therefore rearrange it, y will be equal to 2x, then minus 6, then plus 3. So this will be, y will be equal to 2x minus 3. And this is the equation of L1. Next is part B of the question. So for part B, another line L2 is perpendicular to L1 and passes through -2, 3. Find the equation of L2. For us to find the equation of L2, and since L2 is perpendicular to L1, so the product of gradient of two perpendicular lines, M1 times M2, will give us -1. And therefore, to get for L2, the gradient of L1 is M1, which is 2. So 2 times M2 is equals to -1. Therefore, M2 will be -1/2. So this is the gradient for L2. And therefore, to get its equation, we say let a point xy be on a line with this point given -2, 3. And since the gradient is -1/2, now we can get the change in y, that is y minus 3 all over change in x, x minus 2, that will be x plus 2, will be equal to the gradient, which is -1 all over 2. You can decide either numerator or denominator to have the negative sign, whichever doesn't matter, but you cannot use on both the numerator and denominator. Then from there we cross multiply, we shall have 2 multiplied by y minus 3, then will be equal to -1 multiplied by x plus 2, close the bracket, open the bracket, we have 2y minus 6 will be equal to -x minus 2. Again, we can rewrite it in the form of y is equal to mx plus a constant. So we have 2y is equal to -x minus -2 plus 6. So this is 2y is equal to -x plus, so this will be 4. And therefore, divide each term by 2. So we have y is equals to -x over 2 plus 4 divided by 2, that is 2. So that is equation for L2. Then from there we find the x-intercept of L2. The x-intercept of L2. Now, at the x-intercept that is in the x-axis, y is 0, and therefore we substitute the value of y is 0 into the equation of L2. So the equation of L2 is y is equals to minus x over 2 plus 2. So y is 0, so 0 is equals to minus x over 2 plus 2. So this will be the same as x over 2 is equal to 2, multiply both sides by 2, so x will be equal to 4. And therefore the x-intercept of L2 is 4. Then we do part C of the question. Part C of the question. Determine the point of intersection. So we have noticed that for L1, the equation of L1 we got in part A is y is equal to 2x minus 3, and the equation of L2, find it, it is y is equal to minus half x plus 2. So we need to solve this simultaneous equation, and therefore we equate the two equations. Since the left hand side is equal, we equate the right hand side, and therefore we are going to get 2x minus 3 will be equal to minus a half x plus 2. Collect the like terms and simplify. So 2x have 2x plus a half x will be equal to 2 plus 3. So this is 2.5. X is equal to 5. And therefore divide both sides by 2.5. So x will be 2. So we have found the value of 2x. So let us get the value of y. We can substitute x into one of the equation. So y is equal to 2x minus 3. So let us substitute the value of x. So 2 times 2 minus 3, which is 4 minus 3, which is 1. And therefore the point of intersection is where we have the values of x, y. So that point of intersection is 2, 2, 1. So that is the point of intersection of L1 and L2.
So for question 19, a triangle ABC with vertices A minus 2, 2, B is 1, 4, and C is minus 1, 4 is mapped onto triangle A prime, B prime, C prime by a reflection in the line y is equal to x plus 1. So on the grid provided, so this is the grid provided, we need to draw triangle ABC. Then we also draw the line y is equal to x plus 1. And then triangle A prime, B prime, C prime. Then after that, part B of the question, triangle A double prime, B double prime, C double prime is the image of triangle A prime, B prime, C prime under a negative quarter turn about the origin 0, 0. On the same grid, we are also supposed to draw triangle A double prime, B double prime, C double prime. Then after that, we should be able to state the type of congruence between the triangles actually indicated. So we are going to begin. First, we plot the points ABC, and then we draw that triangle ABC. And therefore, the first thing I'm going to do is to draw the axis.
So I'm going to draw the axis. So from here, let me draw the axis. So the y-axis, let's start with the y-axis. Y-axis. Then I also do the same with the x-axis. So now you have the x-axis and you have the y-axis. Fine. So then we get, here we have 0, 0, such as this is 0, 0, then minus 1, then we have minus 2, then minus 3, then minus 4, we have minus 5, then to the positive x direction we have 1, then 2, then 3, then 4, then 5. Positive y direction, we have 1, 2, 3, we have 4, then we have 5, and the place we have 6. Negative y direction, we have minus 1, then we have minus 2, then we have minus 3, and then we have minus 4. At least I can reach up to that point, and then let me locate point. Now I need to locate point A, which is minus 2, 2, so minus 2, 2, that's where A is, point A. Then I have point B, which is 1, 4, 1, 4, that's where point B is. Then point C is minus 1, 4, minus 1, 4, that's where point C is, minus 1, 4. That's point C. Then I'm going to join the points. So let me join those points. So from A, I join to B. A, I join it to B. Then from B, I join it to C. And then C to point A. So next thing I'm supposed to now do, I'm done with this part. So next thing I need also, I've drawn the triangle ABC, and then I need to draw this line y is equal to x minus x plus 0, and therefore for this line I can write it in the form of y is equal to mx plus a constant. It's already in the y is equal to mx plus a constant. So at the x-axis, I just need to use the intercept. At x-axis, y is 0, and therefore if I substitute into this equation, x will be minus 1. So I need to require that point. So x minus 1, and then when at y-axis x is 0, and therefore y will be 1. So that's where I need to draw that particular line passing through. So that will be, so let me draw that line passing through that particular point. So that's where the line is passing through. So that is it, and this is the y is equal to x plus 1. So that is the line. So from there, we needed to draw perpendiculars,
So that this is the mirror line. So we draw perpendicular line from B. Since for reflection, the object and its image are perpendicular to the mirror line. So for B will be mapped onto two. So this for x, y, that is 1. So we need to draw that line. So that is it. And therefore this is the line y is equal to x plus 1. Y is equal to x plus 1. Then from there, we need to draw the image of triangle ABC, and the reflection is this mirror line, y is equal to x plus 1, and therefore B will be mapped onto, that will be minus 3, 2. So that is where we have B prime, B prime. B prime, then C will be mapped to 3, 0. So it's going to be mapped to, so we have C prime, that is C prime. Then we have A will be mapped onto 1 minus 1, so 1 minus 1, so that's where A will be mapped into. So that is it. And therefore, we join the points. So join A to B, then B to C, and A back to C back to A. So that is the triangle A prime, B prime, C prime. So if you try to draw a line at this point, it is perpendicular to the mirror line. Then triangle, the other one now is a negative quarter turn about the origin 0, 0, and therefore we also need to draw on the same grid. So for A, from this particular point, that is now from the origin so negative 90 degrees, so that's where A will be mapped onto A double prime. Then for B prime, from the origin, B prime from the origin, it will be mapped until that is 2 minus 3. 2 minus 3. So that angle will be 90 degrees. So it will be mapped at this particular point. So that is B prime. Then C will be mapped measure 90 degrees in the negative direction. So that will be at this particular point. So that's where C will be, that is C double prime. And therefore, we are going to join those points. So let us join the points A to B, then B prime to C prime, and then C double prime to A. So that is it. And therefore, after that, you can be able to answer the question, state the type of congruence between triangle. We have the triangle ABC and A prime, B prime, C prime. So for this case, the type of congruence is oppositely congruent, because for it to fit, it must be flipped so that it is fixed to the other one. So that is oppositely congruent. Oppositely congruent. Then for triangle A prime, B prime, C prime, and the other one. So for rotation they are normally directly congruent. So that's how we solve this particular question. So thank you so much. See you. Let us proceed to question number 2.
So for question number 20, the figure below is a right pyramid VFGH with a square base of 8 cm and slant edge of 20 cm. Points A, B, C, D lie on slant edges of the pyramid such that VA is equal to VB is equal to VC is equal to VD, which is 10 cm, and plane ABCD is parallel to the base EFGH. So we are required to find length AB. So how do we get length AB? So we are going to use similarities and enlargement. Similarities and enlargement. And therefore get AB. AB is actually similar to FG, so the ratio of AB over FG will be equal to the ratio now also of the height, and that is for the smaller slant height VC. Now we have that is VC over VH will be the same, and therefore AB, that's what we are looking for. FG is 8 will be equal to VC is 10 and VH is 20. Therefore to get AB is equal to, that is 10 over 20 multiplied by 8, and therefore this we get 4 centimeter. Therefore AB is 4 centimeter. Then from there we go to part B of the question. So for part B we need to find length AC. So where is our AC? Length AC. So for the length AC, this is what we need, length AC. And since we know AB is 4 centimeter, BC is 4 centimeter, we can use Pythagoras theorem. At B it is 90, so we can use Pythagoras theorem to get length AC. So that will be AC will be the square root of AB squared plus BC squared. Since also a square base, and that will be square root of AB is 4, so we square it. BC is also 4, we square it, and therefore we end up getting square root of 16 plus 16, that is 32. So we need to give the answer to 2 decimal places, that will be 5.66 centimeter, and that is the length of C. Then from there we find the perpendicular height of the pyramid VABCD, the perpendicular height. So again, to get the height of the perpendicular height, then we need for that is pyramid VABCD. So it's the smaller pyramid. We need to get that perpendicular height, and therefore from here I can be able to extract a triangle. So from the center there, so the slant length is 10, then AC is 5 point, AC is 5, so we need to let me indicate this as O, and the other one as this is point A, so I need this height here, perpendicular height. So AO is a half of AC, and AC was 5.66, so half of it will be 2.83. So this will be 2.83. Again, we use Pythagoras theorem to get the perpendicular height. So use to get the perpendicular height. So that will be perpendicular height squared, which is VO squared. So it is the slant length or the hypotenuse AC squared minus AO squared, and therefore this now will be H will be the square root of AC is 10 centimeter, we square it, then minus AO is 2.83, again we square it. So if you work out using a calculator, we shall end up getting 9.79 centimeter. So that is H. Then the last part of the question, we're going to look at is the pyramid VABCD was cut off. Find the volume of the frustum correct to 2 decimal place. So to get the volume of the frustum correct to 2 decimal place, then that will be first to get the volume of the frustum. Volume of frustum will be volume of bigger frustum, that's the pyramidal frustum, minus volume of smaller frustum. So I mean this actually the pyramid. We need to find the volume of the pyramid. So volume of bigger pyramid, which is given by formula is given by a third times base area times perpendicular height times the perpendicular height, and therefore this will be a third for the bigger pyramid. The bigger pyramid the base is 8 by 8, and therefore that will be times 8 times 8 times 8 times. Now since the ratio, the bigger height will be twice the smaller height, so that will be 2 times 9.59, which we got in part B, and therefore if we work it out, we end up getting 409.17 centimeter cube. Then we find the volume of smaller pyramid. that will be a third times base. For the smaller pyramid, again the base is 4 by 4, and that is so times 4 times 4. Then perpendicular height of the smaller pyramid, we got it in part B, is 9.59. So if you work this out, we get 51.15 centimeter cube. So to get now the volume of the frustum, we need to subtract the two values. So volume of frustum. So subtract volume of the bigger pyramid minus that of the smaller pyramid, and therefore subtract, we get 2, 0, get 8, then I have 5, then 3, and that is centimeter cube. So that is the volume of the frustum.
So for question 21, the height of 40 athletes in a county athletics competition was shown in the table below. So that is the table for the height in centimeter and the number of athletes. So we are required to find the value of x. So to get the value of x from the table, here is where we have x. So this is x, and we need to find that value. So if you had the frequency, all the frequency 2 plus 8 plus 10 plus x plus 6 plus 2 should give us 40. And therefore, that is 2 plus 8 plus 10 plus 6 plus 8. That is 28. Then plus x should give us the total number of athletes, which is 40. And therefore, x will be 40 minus 28. So x is 12. So there are 12 athletes in this class 82, 189. Then we are required to state the model class. So for the model class is the one with the highest frequency, and therefore here x is 12, and among the others 12 is the highest. So the model class is 180 to 189. It is in centimeter. Fine. Then from there we are supposed to calculate the mean height of the athletes. First, to get the mean height of the athletes, so the mean height is given by sum of x divided by sum of f, and therefore we need to modify the table such that we have f. So let us modify the table. Since this is a grouped data, we need to find the mean point x, mid x, and therefore 150 plus 159 will be divided by 2, we get 154.5. 160 plus 169 divided by 2, we get 164.5. The other one will be 174.5. The other one will be 184.5. Next 194.5. And the last one 204.5. So those are the mid x. Then from there now we multiply by the frequency f, so we need to have fx. So 2 times 154.5, we get 309. Then 8 times 164.5, we get 1316. 10 times 174.5, we get 1745. Then x, which is 12 times 184.5, we get 22, 14, then 6 times 94.5, we get 1167, then 2 times 2 or 4.5, we get 409. So from there, now we need to get sum of fx. Using a calculator, you add all these values for fx, you get 7160. Here the sum of the frequency is actually 40 if you add all of them. And therefore, now we can go back and answer the mean value of the data. So sum of fx is 7160. We divide by sum of f, which is 40. So if you work it out, you will get 179, that is centimeter. Then the last part of it, we need also to determine the median height, correct one decimal place on the grids. So for us to get the median height, one thing we need to do is to get the median position. So median position, and the median position is given by a half n over 2 or a half of n. So there are n values, 40 values, so 28th position. So we need to get the 28th position, whereby we shall use this formula to get the median, lower class boundary of the median class plus n over 2 minus cumulative frequency preceding the median term over frequency of the median value 10 times the class interval. And therefore, from the table we need again to modify it. Let us modify the table again so that we have another column for cumulative frequency. For cumulative frequency, we start with the 2, then 2 plus 8 is 10, 10 plus 10, that is 20, 20 plus 12, that is 32, 32 plus 6, that is 38, and finally 38 plus 2, that is 14. So the median class, which is the 20th mark at this point. So this is the median class. So that's our median class. And therefore, let us identify those. So lower class boundary of the median class, lower class boundary will be 169.5. 169.5, and therefore that is 169.5, then plus n over 2, that is 40, minus cumulative frequency preceding the median class, that is cumulative frequency preceding coming before the median class is 10. Is 10, so that will be minus 10. Then divide by frequency of the median class. Frequency of the median class is the median class. If the frequency is 10, so it is 10. So that is 10. So n over 2 is actually 20, 20 minus 10, 10. Then everything multiplied by the class interval. For the class interval, we get class interval of upper class limit minus lower class limit 189.5 minus 179.5. You can pick any class and get the upper limit and lower limit, then subtract. We shall get it is 10. It is 10. So times 10. Then from there we have 169.5. Now plus 20 minus 10, that is 10. 10 divided by 10, that is 1 times 10. We have 10. And therefore this will be 179.5 centimeter. So that is the median of the data, median height. And we have given the answer to correct to 1 decimal place. Then we proceed on to question number 22. Question number 22. The figure below represents a triangular floor garden ABC in which AB is 4 cm, BC is 5 cm, and angle BCA is 30 degrees. Point D lies on AC such that BD is 4 cm and angle BDC BDC is obtuse. This angle is obtuse. That means obtuse angle is an angle which is less than 180 and greater than 90. So, part A of the question we need to find correct to 2 decimal places angle BDC. So for angle BDC, I'll consider triangle BCD, and therefore I have this side opposite to angle D. Then I also have the other side opposite angle, that is 4. Therefore I'm going to use sine rule. That is, I mean, side BD divided by sine that angle D will be equal to, then the other part is BD, side BD, which is 4 cm over sine 30 degrees. Therefore, BC will be given by 4 so now BC is 5 over sine D is equal to 4 over sine that. And therefore, to get sine D now will be cross multiply, we shall get 5 sine 30 divided by 4, and this, if you work it out, you get 0.625. Therefore, we need to get angle D, which will be sine inverse of 0.625. So D is an acute angle, so which is 38.68 degrees. But the angle here is BDC is an obtuse angle, and therefore angle BDC will be 180 minus 38.68 to get the obtuse angle. That is 141.32. Then we get the length AB. length AD. So to get length AD, right at this point here, this angle is 8. So that's something very important we need to know. We need also to get this angle here, and therefore so if you consider triangle ABD, this side are equal, that means they are isosceles. So these are base angle of isosceles triangle, and therefore to get this angle, already this angle here is 38.68, is 38.68. Therefore to get angle ABD will be 180 minus 2 times 38.68, and therefore working it out get 102.64 degrees. So this angle is 102.64 degrees. So that will help us work out now the length AD. So we have two sides, we have and an included angle. So we are going to use the cosine rule. So for cosine rule, we are looking for side AD squared will be equal to square of the two sides AB squared plus BB squared, then minus 2 multiplied by side AB times side BB cosine this angle cosine B. So now let us substitute into, so AB is 4 squared is 16 plus BD is 4 squared is 16 minus 2 times 4 times 4, that will be 32, then cosine B is 102.64. Now let us work out these values, and therefore if we use a calculator we get 39.00, and therefore to get the AD will be the square root of 39.00, and that will give us 6.24 meters. Then we find the length of BC. The length of BC. Length BC. We need to get that length. Already we have this side, we have this side, we have this angle, we have also this angle, so we can get the other angle, can get this angle. So we already have this opposite angle, which was 141.23 and plus 30, so that is 171.82. Subtract it from 180, we are going to get 8.68 degrees. So this small angle here is 8.68 degrees. And therefore, let us get the length of DC. So this is B, we have D, and we have C. This is 30, This is 5. For this angle is 8.68 degrees. Therefore, I'm interested to use this angle and opposite this side. So again, we are going to use sine rule, and therefore the length DC over the angle opposite DC is 8.68, so over sine 8.68 will be equal to, now the other angle, the side opposite to angle that is 4, so we have 4 over sine 30. And therefore, for this one will be DC will be equal to 4 sine 8.68 over sine 30. And if we work it out to 2 decimal places, we shall get 1.21 meters. And later, part D, we find the area of the flower garden A, B, C. To get the area of the flower garden, now the area will be given by, now we can be able to use, I have a B sine theta, I have a B sine theta, and in this case, I have the area of all the, I have a B, so we shall consider the angle at B, and this side AB and BC. The angle at AB, that will be 102.64 plus this angle which is 8.68, and that angle is 2, 3, then we have 111. So that is 111.32, and therefore so we have a half times AB is 4, and then BC is 5 times sine 111.32. So if you work it out, you should end up getting 9.32 meters squared, and that is the area of the flower garden. Then we proceed on to question number 23. Question number 23. So for question number 23, the shaded region on the graph below shows a piece of land ABCD marked for building a sub-county hospital. So that is it. So part A of the question, we write down the ordinates of curves AB, the curve AB, and then we have DC. For the values of x, these are the value of x in meters, 0 to 200, 400, 600, 800, 1000 and 1200. And therefore, let me just make a table of it. So for x, values of x, we have from 0 to 100, we have 400, 600, 800, 1000 and 1200. So we need to get for the curve AB ordinates for AB and also for the other one is DC. So what are those ordinates? So for AB, this is the curve AB, and the other one is DC. So for AB, when x is 0, the ordinate is 200. That is the height. The ordinate is 200. For DC, it is. Now the other thing you need to note for DC is 400. It's 400. Then when x is 200, so for the ordinate for AB at 200, x is 200, yet is 240. That is 240. For DC, it is 500. Then for 400, when x is 400, the ordinate for AB at this particular point, that is 280. For DC, point that is 580. When x is 600, the ordinate for curve AB at this point, it is 300. That for DC, curve DC, is 600. Then for 800, curve AB is 280. For DC, it is 580. Then for 1000, for ordinate for curve AB, that is 240. For DC, curve DC at 1000, it is 580. And lastly, for AB, when x is 1200, it is 200. And for curve DC, it is 640. So that's what we have. Now, we proceed on to the next. So we are going to use trapezium rule with 6 strips to estimate the area of the field of the land. So for 6 strips, here we need to have y0, y1, y2, y3, y4, y5, y6. So those strips, we can be able to get the difference of the curves, the ordinates of the curve DC minus AB, and therefore if we subtract, that is 400 minus 200, we get 200. The other one we subtract, we get 260. 580 minus 280, we get 300. The other one will be 300. The other one again will be 300. The other one will be 340. And lastly, we shall have 440. So using that trapezium rule, the area using the trapezoidal rule, it's half the width of each strip, then the bracket, we take the sum of the first ordinate y0 plus the last ordinate, for this case is y6, and then plus now twice the sum of the other ordinates, y1 plus y2 plus y3 plus y4 plus y5. So if we do so, So this will be a half of. Now the width. In this case, the width for each strips. So we have the first strip, second, third, fourth, fifth, and sixth. So for each strip, so there the width is 200 minus 0, so that is 200. Then we have the first ordinate and the last one, so 200 plus 440, which will be 640, then plus twice the sum of the other ordinates, y1 to 60 plus 300 plus 300 plus 300 plus 640, we get 1500. And therefore, to work it out, a half times 200, that is 100, plus 640, plus 2 times 1500 is 3000. So if we get 100 times, this will be 3640. So if we multiply, we end up getting that 640, 00. So that is meter squared. But the answer requires us to set it in hectares, and 1 hectare is equivalent to 10,000 meters squared. So we are going to divide by 10,000, so that now we have the values in what? So that is per hectare, and therefore we get 36.4 hectares. Then the last part of it, of this question, we use the mid-ordinate rule with 3 strips. So we are going to use the mid-ordinate rule with 6 strips. Mid-ordinate rule with 3 strips. 3 strips to estimate the area of the land in hectares. So for mid-ordinate rule, area will be given by the width of each strip multiplied by sum of the mid-ordinate, y1 plus y2 plus y3, since we just need 3 strips. Now, from previous work we had, if you consider them into 3 strips, then I'll have this part to that point, then the other one I'll pick from this point up to that point, and the last one from that point up to that point. So that's the idea. So here we have the first, then the second, then the third. So that's what we are going to consider. So for x is 200, the other one. So between the width of 0 to 400, therefore already h is 400 meters. Then we need y1, y2, and y3. So y1, so here we have, at here it is y1 is 260, the other one is 300 and 640. So we have 400. Then y1 is 260 plus y2, the mid-ordinate, y2, so it is 300, since we get the difference, 300. Then y3, it is 340. So this will be 400 times the sum of 260 plus 300 plus 340, that is 900. We multiply, we get 36,000, that is 360,000 meter squared. But 1 hectare is equal to 10,000 meters squared. So divide by 10,000 meters squared per hectare, and therefore we get 36 hectares. Lastly, get to question number 24. For question number 24, the equation of a curve is y is equal to x cubed plus x squared minus x minus 1. So we need to determine the stationary points of the curve. Let us get the stationary points of the curve. So at stationary point, dy dx, the derivative of the function is 0. That is, the gradient function is 0. And therefore, let us get the gradient function of the curve. So dy dx is, we differentiate, this will be 3x squared, then plus x squared, we differentiate to get 2x, then minus x, we get minus 1. And the gradient function of a constant value is 0. So that is the gradient function, and this we equate to 0. So now we are going to solve for this quadratic equation. So I'm going to use the factor method. So let me get the product. AC is minus 3. Then I should get some factors that when I add them, I get 2. And therefore the factors will be 3 and a minus 1. So let me write it in the expanded form. That will be 3x squared minus 3x, plus 3x, then minus x minus 1 is equals to 0. So I factor out 3, take into pairs, and factor out common factor. So 3x squared and 3x is common. So I have, this will be x plus 1. So the bracket again, the other part, minus 1 is common. We have x plus 1 will be equal to 0. Therefore, this is 3x minus 1 multiplied by x plus 1 is equal to 0. Therefore, x will be hazard or minus 1. We are not yet through, so we need to get the stationary points. So when x is hazard or 0.3 with a dot at the top of 3 to show that it is recurring, then y will be, we substitute now into the original equation, and we shall get y as minus 32 over 27 of this is minus 1, that is minus 1 and 5 over 27 in the simplified form. Then when x is minus 1, y again we substitute into the equation of the curve. We shall get y is 0. So the two stationary points are, we have hazard and minus 1 and 5 over 27, The other stationary point is -1, 0. So those are the stationary points. Then the nature of the stationary points. So for us to get the nature of the stationary points, we need to look at each of the points, whether it's a minimum point or a maximum point. And in that case, we need to look at the nature at that particular point, and therefore allow me to consider some few values. Here we have -1, the other one is hazard, so I can have -2. I can also have now -1, then I can have 0. So for the other values, I can have here, I can have the hazard, and then 2. At least now I have that. Then dy, what is the gradient function at that particular point? So the gradient function, so for the first one, substitute into this, then when x is -2, the gradient function is 7. Then when x is -1, the gradient function is 0. When x is 0, the gradient function is -1. When x is a third, the gradient function will be 0. When the gradient is, x is 2, the gradient function is 15. And therefore, the nature of the root here, it is a positive, it is also positive gradient. So the nature for positive gradient, and this is the graphical representation, diagrammatical representation. Here the gradient is 0, then here it is negative. That's how it is. Then the other one is, it is the minimum, and the other one is positive. Therefore, for a third -1, 5/12, over 27, when x is a third at this point, it is actually a minimum point. So for this, it is a minimum, that point is minimum. Then the other one, -1, 0, -1x -1, it is maximum. It is a maximum point. Then part B of the question, we determine the equation of the tangent to the curve at x is equal to 1. So at x is equal to 1, y is, at x is equal to 1, the value of y is 0. And therefore we substitute into the gradient function at that particular point what is the gradient of the tangent is drawn. So 3 x is 1, so 1 squared, plus 2 x is 1 minus 1. So the gradient function at that particular point, 3 minus 2 plus 2 minus 1 will have 4. So the gradient function at that particular point is, so we take the 2 points, 1, 0, and then an arbitrary point xy, and the gradient is 4, so change in y minus 0 divided by x minus 1 is equal to the gradient of the tangent, and which is 4, and therefore we get y will be equal to 4x minus 4. That is the equation of the tangent. Then the equation of normal to the curve at x is equal to 1. So note that the gradient of normal and that of the tangent at x is equal to 1. So if the product will give you -1. Therefore, gradient of normal times that gradient of a tangent gives you -1. Therefore, the gradient of the normal will be -1 divided by the gradient here, it is 4. So that is the -quarter. Again, at the same point, we have that point 1, 0, and take an arbitrary point x, y. So again, we find the equation. So change in y minus 0 divided by x minus 1 is equal to the gradient is -1 over 4. Cross multiply, I have 4y is equal to -x plus 1. Therefore, divide both sides by 4 each time. So y will be equal to -1/4 x plus 1/4. And that is the equation of the normal to the curve at x is equal to 1. So thank you so much for watching out this video, and let us see each other in our next tutorial. Thank you.